Hello children, welcome to channel Sube. Children, today I am going to discuss question number 17 from the MCQ part of 2022-23 Physics new syllabus paper. The period of oscillation of a simple pendulum of length L is capital T. Suppose a simple pendulum of length 2 times L is hung from the ceiling of an elevator. What will be the period of oscillations of this pendulum if the elevator accelerates vertically upwards at g divided by 2? So there are 5 answers. Children, let us draw a little sketch for this. The first pendulum is normally it is in the atmosphere where the acceleration is g, that is the gravitational acceleration. So the length is L. So the period of oscillation they have given as t, but we know the equation is t equals 2 phi root L divided by g. So that is normal. We know, everybody knows this equation and this condition. So there is another elevator, there is another pendulum which is hung in an elevator, so like this, so whose length is 2 times L. So the external acceleration is g, gravitational acceleration, that is, so that acceleration is there inside the elevator as well. So the elevator is moving upwards with an acceleration g divided by 2. So in this frame the resultant acceleration is, we have to add these two, g plus g divided by 2. So 1/2 g, that means 3 divided by 2 times g. So there is the acceleration in that acceleration that feels to this pendulum. So if you don't understand it, suppose let us talk about velocity. So suppose there is a vehicle moving, say vehicle B moving right side at a velocity v. So there is another vehicle moving left side, moving to left side, say A. So there is an observer in that vehicle looking at this B, looking at this B. So the velocity of this vehicle is, suppose same speed, but the direction is opposite v, velocity is v to the left side, the velocity of this one is also v to the right side. So what does this feel? How does this measure the velocity of this B? Velocity relative to A, velocity of B relative to A is, this one is relative to A, is 2 times v, 2 times v, because this distance is increasing by this one and also by this one, both are helping to increase this distance. So the increase of this distance per second is the velocity as this one is measuring, so it is equal to 2 times v. So like that, these accelerations are opposite to each other, therefore we have to add to get the resultant acceleration. So the equation now, let us substitute to the equation. Suppose the time is the period is t2, 2 times phi root, so length is 2 times L, so the acceleration is this one, 3g divided by 2. So let us simplify, root 2L divided by 3g, so this 2 goes to up, so like this to the numerator, So 2 phi, let us separate L divided by G times root the other part of the term. 2 times 2 is 4 divided by 3. So this term is equal to, previously we had this one, so that is capital T, it is equal to capital T, period of the first one. So times root 4 is 2 divided by root 3, we leave as it is. So 2t divided by root 3 is the answer. That is the T2, that is the period of the second pendulum. So 2t divided by root 3, this one is the answer, the fourth one. So question number 17, fourth one is the answer. So like that we can solve it, children. It is not a difficult question. If you know how to get the resultant acceleration like this in such a frame, it is not a difficult question. So children, today I am not going to give you target questions, because this question is not a difficult one. So children, I think you are happy, because today the question is easier and the video is shorter. So you have to make me happy too by subscribing my channel if you haven't done it still. Then thank you very much for those who watching my videos, and thank you very much for subscribing my channel, and share my link among your friends, and press the thumb up icon, and also press the bell icon, and see you tomorrow in the evening at 6 o'clock to solve the next question, question number 18. So goodbye children.